We're back. We're on page 101, and I was just telling the kiddos that we're actually doing math today. Less talking, more mathing. So, we've talked about our population and our sample. So, we want to know something about a population. We take a sample. There's a good way to take a sample. There's a bad way to take a sample. And even if you do it the good way, you still might have some issues, like question wording or response bias or people not answering the phone. So, we now know the basics of gathering data. Now, on this page, we're going to look at what we do with that data. And most of the time, what we do with that data is we graph it. So here are 4 graphs. Do you guys know what these graphs are called? Nope. Starts with an H. I mean, they look like a bar graph, but they're not. They're histograms. I like to call them histogrammies. They're histograms. Now, I'm not going to test you on that. You're never going to have to label that as a histogram. I'm just letting you know what the real world is. The real word, not world. Okay, so the shape of your data, the shape of your Instagram, they have names. So we would say that the shape is the distribution, and we can describe the distribution. So in this case, we're going to imagine a little skier skiing down the mountain. And if he was skiing down the mountain, he's skiing to the left. Know what I'm saying? He's going this way down the mountain. So we would say this is skewed left. Skewed left. So S-K-E-W-E-D. Skewed left. Because our little skier guy is skiing to the left. So this is one shape that our data could look like, or our distribution. So we gather all the information from the people, we put it in a graph. One graph could look like this. If this guy is skewed left, then this guy is skewed right. And if we think about the skier again, he's skiing down to the right. So skewed right. Now, we don't prefer these two, skewed left and skewed right. They aren't really good situations for analyzing data. We don't want our data to have a bunch of values on the left and then be dragging itself out on the right. We want our data to look more like this guy, the last histogram. So if we draw a curve over him, he's got like a little, I don't know what we'd call that, kind of a cone shape. He's not skewed to the left, he's not skewed to the right. He's looking good, Hugo. This one's looking good. This guy's got a funny name. We would call this guy bimodal. Bimodal. You don't got to memorize these names. Bimodal. This guy's bimodal because he's got 2 little, like, peaks going on. He's got, like, one mountain here and one mountain there. So really, the one that's the best, the one that we would prefer our data to look like, is this guy right here. So why do we prefer this guy? Well, we prefer this guy because most of the data is in the center of the graph. And then as we move out from the center of the graph, our data tapers off nicely, and this is what we would call roughly symmetric. Because if we folded him in half at the center, his sides would line up okay. They wouldn't be perfect, but they would be okay. This is the only distribution that we're going to talk about because this guy is the most desired and most important distribution. So that's what these blanks are going to describe. It's going to describe what's special about this distribution. So data that tends to be around a central value central value with no bias left or right. So that means it's not skewed to the right or skewed to the left. So when you have no bias and your data is around the center of the graph, you call this bell-shaped, because it literally looks like an old school bell. So I gave you a picture of a bell right here. This is what they mean by bell-shaped. You're okay there? You're sure? Okay. So if it's central, gathered all the data's around a central point with no bias, your distribution is said to be approximately normally distributed. So this big blank is the word approximately. So this guy is called the normal distribution. We can also refer to him as a bell curve. So normal distribution or a bell curve. So his key characteristics is that most of the data is around the center. So like we would consider this to be the center. It's what they mean by the data tends to be around a central value. And then if you notice, your tails or your sides are about the same size. One doesn't drag out further than the other. That's a bell curve or a normal distribution. So this is going to list all the important things about the distribution. So this blank is the normal distribution is bell-shaped, unimodal, meaning it has one peak, and symmetric. Unimodal, U-N-I-M-O-D-L. Bell-shaped, unimodal, and symmetric. It has a mean, and I'm going to introduce you to some symbols now, a mean mu. So let me draw that symbol out big for you so you know what I'm actually drawing. So the mean is called mu, like mu. Like that's how you would spell it phonetically, mu. Its real spelling is M-U. Here's what it is. You have a little tail in the front. You make like a U shape, and then do a little tail on the end. See what I'm saying? I think it might be a fancy U. I'm not sure though. But it does look like an M. But he's fancy. So don't be doing this. That's not mu. Okay? Yes? Okay. His standard deviation is named sigma. So sigma is this guy. He's like a circle with like the bill of a hat. No hat, just the bill. Know what I'm saying? That's sigma. So, standard deviation tells you how spread out your data is. Standard deviation describes how spread out your data is. So we have a mean of mu and a standard deviation of sigma. The area under the curve. So notice up here we have the curve drawn. The area under the curve is 100%. That is just a fancy way of saying 100% of the data is under the curve. So this thing, this bullet point is a fancy way of saying 100% of your data is under the curve. Now here's what we're spending the entire rest of the day on, these next 3 bullet points. All normal distributions have 68% of your data within 1 sigma of the mean. Within 1 sigma of the mean. If we go out 2 sigmas, that's 95% of the data. And if we go out 3 sigmas, that's almost all of the data. That's 99.7% of the data. So I'm going to build this graphic that you see here because you're going to use this graphic a ton to solve problems today. So I'm going to draw a basic normal curve, and you're going to watch because one of the most important parts about today is understanding what I'm about to draw. So here's any normal curve. Underneath this curve is 100% of the data that you gathered. Does that make sense? You graph all of your data and it makes this shape. Are we okay that far? Okay. In the very center of this distribution is mu, is your average value. So if I wanted to find an average value for this classroom, I could average the amount of sleep you guys got last night. So if that's the case, I would say mu is probably 7, maybe 6. So the average amount of sleep you got last night was 7 hours. You're still hanging in. Yes? 1 standard deviation looks like this. If you go a little bit to the right and a little bit to the left, this is what we call 1 standard deviation. So 1 sigma, negative 1 sigma. And what they're telling us is that 68% of the kids in this class will be within this amount of 7 hours of sleep. So maybe this is 6.5 hours and this is 7.5 hours. So what we would say is 68% of the kids in this class slept between 6.5 hours and 7.5 hours. Does this make a little bit of sense? If we go out 2 standard deviations, now what we can say is that 95% of you in this class got between 6 hours and 8 hours of sleep. And then the last thing that they tell us is that if we go out 1 more, that is 99.7% of the people in this class. So almost everybody got between 5.5 and 8.5 hours of sleep last night. Is this making a little bit of sense? Yes, no? All normal distributions work this way. Every single one of them is 68, 95, 99.7% of the data. You're hanging in? Okay, that's what this picture down here at the bottom of your paper is trying to show you. They're saying, okay, in the center, you have your mu, and 1 standard deviation away would be your average value plus your standard deviation. This would be 2, this would be 3. And this will make more sense once we do our first one. So let's see what that looks like on the next page, page 102. So IQ is normally distributed with a mean of 100 and a standard deviation of 15. So our center is 100, and our spread, our standard deviation, is 15. So we could name this normal curve with a capital N, parenthesis, 100, comma, 15. What this means is your mu is 100, your sigma is 15. That's how you name a normal curve. You write capital N for normal, you give the center and then the spread. Then this problem wants us to label this normal curve. So every normal curve looks similar to this. We have a tick mark right in the center. That is 100. Tick mark right in the center, that is 100. Then you'll notice to the right there are 3 tick marks, and to the left there are 3 tick marks. That third tick mark is just really hard to see because it's at the very end. So now we're going to label these tick marks with the appropriate IQ score. So this is 100 right in the middle. That's the average IQ. 1 standard deviation would be 115 on the right and 85 on the left. How am I getting that? Because I take 100 plus 115, 100 plus 15, 100 minus 15. Is that making a little bit of sense? So I usually do it all at the same time. So to find my standard deviations to the right, I would do 100 plus 15. Sorry, let me clear that. And that would give me 115. And then I would plus 15 again. So your next one is 130. And then I would plus 15 again. So your next one is 145. Is this making sense what I did? Okay, so now you do the lower end. So you find the tick marks to the left. Is 70? Is that true? Sorry, 2 standard deviations, is that 70? No. Well, what's 85 minus 15? I don't know. 100 minus 15. That's 85 minus 15. That's 70 minus 15, 55. You're hanging in? Yes? Okay, so let's maybe answer some questions. Do I want to do that? Nope, I don't. Just kidding. We're going to go to the next one and answer these questions. So the next one says the average temperature in Salt Lake City is 90 degrees with a standard deviation of 3. So this normal curve's name is 90, 3. So you guys now label this normal curve. Remember, 90 is in the center. So you're labeling the values on that normal curve. Is 10 seconds enough? 5, 3, 2. Okay, so what's one above? 93? 96. What's the last one? What's negative 3 sigma? 84? 84 or 81? Which one is it? 81. So your numbers start at 81 and go all the way up to 99. So part A says label the normal curve. Part B says what percent of the days are between 90 and 96. So I'm going to highlight that on my normal curve. So that looks like 2 standard deviations above the mean. How much percent is that? Well, I'm not really sure because the last thing that you told me, teacher, was this 68, 95, 99.7 business. Well, there's something that we can take from that. So, if this is our normal curve, and this is 68% of the data, what is in each section? So if the thing together is 68%, how much is in this section of the normal curve? 34. And how much is in this section of the normal curve? 34. So we know that if we break out our standard normal curve, just our normal curve, this is 34% of the data, and this is 34% of the data. So we could say here, well, we know that this one is going to be 34%. So we're going to write that down, 34% plus, well, now we need to know what's in this part of the standard normal curve. And if you go through and do all the math, which I'm going to save you from, you will figure out that in that section of your normal curve is 13.5% of your data. So you go through, or not go through, but you guys add those. Tell me what you get. What did that one equal? 47.5? Did you guys write that down? So if you add those, you get 47.5. 47.5% of the days are between 90 and 96 degrees. So if you get a question like this again, this is how the percents are broken down for every single problem. Each one in the center is 34, and then as you move out, each one is 13.5, then 2.35, and then there's a little smidgen of percent, like so small on the very ends that you got to be really careful not to forget about. Are you hanging in? Okay, this one wants us to tell them how many days are between 90 and 96. So April has, just kidding, August has 31 days? Or 30 days? Are you sure? It has, yes, you're right, it's 31. So we're going to do 47.5 over 100 times 31 days. So you have to have your percent over 100 or it won't give you the right answer. What'd you guys get? I'm not going to give it to you because you can do it. Anyone? Bueller. Bueller. What'd you guys get? How many days? Thank you. 14.725 days. I'm not going to round. I'm just going to leave it like that. Okay, next up. A fire department in a rural county, that should say county, claims their response time is at most 15 minutes. The actual response times for the department are normally distributed with a mean of 22 and a standard deviation of 7. So we have N 22,7. What percent of the times are 15 minutes or less? So we need to put 22 in the middle of our curve. And find your standard deviations. So I'm going to walk through to verify that you guys can find these. Okay, let's go about 30 more seconds. About 10. Okay, so I have from 1 to 43. Is that what you guys have? Okay, they want to know the percent of times that are 15 or less. So they want to know this area. So I'm going to use this normal curve that I brought you guys to figure out what those percents are. So this one between 8 and 15, that's 13.5. Then between 1 and 8 is 2.35. And then at the very end, there's this little teeny tiny amount of 0.15. So you're adding together 13.5, 2.35, 0.15. What do you get? How many? 16. Do you guys agree with Cheyenne? Did you get 16? Yes, no? So 16% of the response times are less than 15 minutes. They said that their response time is at most 15 minutes, but they only go to 16% of their calls in less than 15 minutes. That's not very good. Are you ready for the next one? Was that a yes? Okay. Suppose that a distribution of test scores is approximately normal and the middle 95 are between 72 and 84. Calculate the following percents. So, let me just tell you what's in the middle. Your mean is 81.5. Is that true? No, don't write that. Your mean is 78. So capital N 78, comma, your standard deviation is 3. So now we got to draw our own normal curve. It doesn't even got to look that nice. Mine doesn't even look that nice. And right in the center, we're going to put 78. So 1 sigma above would be 81, 84, 87. $69 is our lowest. Okay. So now it wants us to calculate. So I think that you guys should try A, B, C, D. Distance learners, I'm going to pause while they work on it so your video isn't 8 years long. I forgot to hit record, distance learners. These are the answers. My bad. So now we're doing the laptop problem. The laptops have a mean battery life of 28 months with a standard deviation of 9 months. So we got to draw our own normal curve to answer these questions. How long will the middle 99.7 last? 1 to 55 hours. So you look at these, if you're confused about where I'm getting them, 68% of the data is 1 sigma. So on my graph, 1 sigma is 19 to 37. 99.7% of the data is 3 sigmas. So 3 sigmas is 1 to 55. What percent will last more than 37? So what percent is more than 1 sigma? So I add up 13.5, 235.15. That gives you 16%. What lasts, just kidding, how many last more than 28 months? Well, more than 28 months is in the middle, so to the right is 34, 13.5, 2.35, 0.15. You add all those together, that's 50%. So 50% of 500 laptops is 250 laptops. You can skip the Abby and Kirk problem and go to the AP chemistry exam problem. So the scores on your AP chemistry exam are approximately normal with a mean of 150 and a standard deviation of 15. So this is our last practice problem. I'd really practice it because the quiz questions are not a walk in the park, just saying. And some of y'all are doing nothing. I mean, what's the point of that?
I'm gonna come walk through in about 30 seconds to see where you're at. About 30 seconds. About 10. Okay, I got above 180 was 2.5%. Above the mean, so the mean is 150. Above the mean is 50. Below the mean is 50. Between 120 and 165, I got 81.5. Between 105 and 135, I got 15.85. Is that what you guys got? Okay, the first few on your quiz are easier, and then the last 2 or 3 are like these guys. So it would be helpful if you drew out a normal curve. Know what I'm saying? Yes. Know what you're saying? Yeah. Okay, go.